Hello everyone, JCE Connect. I welcome you all for this particular lecture. So in previous lecture, we have been derived some of the conditions of open channel flow, and that is a critical depth. We have derived based on the specific energy curve, that is critical depth as a YC, then the critical velocity VC, then the minimum specific energy in terms of critical depth. So in this particular lecture, I will be deriving a equation for maximum discharge, that is condition for maximum discharge. So from the previous lecture, uh, we have been taken this condition for minimum specific energy. The minimum specific energy condition is q square divided by g is equal to a cube divided by t. This was the condition we have obtained in uh, while deriving the uh, equations for minimum specific energy. So this was the condition. So by utilizing this condition, you can get the critical depth also, critical velocity, and minimum specific energy in terms of critical depth. So now next is condition for maximum discharge. So to get condition for maximum discharge, so this is the specific energy equation we are having, that is E equal to y plus v square by 2g. So where q equal to a into v, from this you get v equal to q by a. Substitute this in this equation, we get this one. Then discharge equation can be obtained from the specific energy equation, that is q equal to root of 2ga square into bracket e minus y. So we want maximum discharge. So for maximum discharge, the condition is dq by dy is equal to 0. This is for maximum discharge. When you differentiate this equation with respect to y, so differentiate this equation with respect to y. Let us consider this one as a root of x. So we know the formula, that is differentiation of root of x. Differentiation of root of x is what? 1 divided by 2 root x. That is 1 divided by 2 root x. So similarly, you differentiate first this one. Here we have what we have done. We differentiated first this root 1 divided by 2 root x. Then the differentiation of x is what? 1. Similarly, to differentiate, so when I differentiate this one, I get half into 1 divided by 2 root of 2ga square e minus y. Now differentiate, uh, next to differentiate the term inside the bracket. So differentiate this term, then you apply u into v formula, this product rule you apply. So u into dv by dx plus v into du by dx. So for this one you apply product rule. So I get 2g, then a square, just 2g take it out is a constant, then a square, then the differentiation of minus y minus 1 plus e minus y, then 2a, that a is a function of depth, then differentiate with respect to y, 2a into dA by dy is equal to 0. Next, when you simplify this one, if you simplify this one, what we get here, we get e minus y into dA by dy is equal to a by 2, or what we get e equal to y plus a divided by 2t, because dA by dy, because dA by dy is equal to what? Top width. This we have seen in previous uh, lecture. So dA by dy is equal to what? Top width of the channel. If you substitute, you will get e equal to y plus a by 2t. Then comparing this equation, that is, write it once again, e equal to y plus a by 2t. So comparing this equation with, just to compare this equation with what? E equal to, let this one, this equation with E equal to y plus q square by 2g a square, just to compare this and this. What we get here, when you compare, we get E equal to E, then y equal to y, same. We get a by 2t is equal to q square by 2g a square. So again, if you simplify this one, you will get q square by g equal to a cube by t. Okay. So this will be the same condition as that of minimum specific energy. So this will be the same condition as that of minimum specific energy. So for maximum discharge condition also, we have got the same condition as that of minimum specific energy. Hence, one can be remember that at critical flow condition, so we can write, so this condition is same as that of minimum specific energy. So one can be remember that the specific energy is minimum for given discharge. And second one, the discharge is maximum for a given specific energy. So from this equation you can conclude that, so this same equation can be used for minimum specific energy also, and the same equation also been using to get a maximum discharge in a channel. So that's why it is given here, the specific energy is minimum for a given discharge, and also the discharge is maximum for a given specific energy. So these are the conditions for getting a minimum specific energy as well as a maximum discharge. So I hope you understood these all. So please practice these derivation. So these are very important for the examination point of view. So with this, next lecture I will be solving problems on this specific energy conditions. Thank you.